I'm Jie Hu from ZT Corporation. It is the first time I try to share my my idea to the folks in the open source community, like this summit here. My topic is to show you the ideas how improve the trust of the network by using the method of open source and standardizations. Firstly, I should give you some background of a network and show you the giant network can help our to generate a very large scale of economy and help. We have an ecosystem with super large values. Anyone is not familiar postal? This is the UPU, the Universal Postal Union. It's date back about 150 years, and it set up the largest network across the globe. Even now we have internet, but we still use this infrastructure to connect people. Can we replace it with other network? I don't think so. Since it connects people by using transportations, by ships, planes, and trains, trucks, and all the ways of the transportation method to deliver goods, letters, as parcels. Everyone has a post address. Then you can connect it with these networks. So this is the, I think it's the first largest network structure we have in our world. Then we have a little bit modern networks to keep us gather information in somehow a real time. That is a message network. It actually is a telegraph networks. You see the map, the global map, they're connected with cables underneath the bed of the sea, the oceans. And in the left side, you can see the Morse code and the Morse keys. And in the meantime, some guys help us to set up the wireless networks for our world. And also, if you remember, in about 30 years before, the telegram is popularly used. You should keep the message very short in code to transfer messages. Especially, this is important for business, doing business to the other party across the world. Then we have telephony network. This network help us to connect people with voice, with your voice. It's almost in real time. And on this network, the telco developed a lot of service like customer care center and maybe some transfer videos. And it is very interesting that we have a country calling. Every country has a calling code. You can call out of your country and be called from the other side from the world. The different color shows the a tree of the coding, the numbering systems. For example, in the North America is +1, and in Africa is +2. Yeah. This network is maintained now with a lot of standard developed and within the ITOT now, the International Union of Telecommunications. Then we come to the age of the internet. Thanks for the internet, then we can have more information connected with the world. It basically is a data network. It can transfer contents, messages, anything in the IT network, IT world. And right of the picture shows the network developed. It's like nebula. And every node on the network has address in format of IPv4 address or even IPv6. Then we come to the word to the wireless. The cellular networks, it's not a standalone network. It extends in the U with mobilities. You can reach the network to the telephone network, voice network, or the data networks with generations of the wireless technologies. It developed as a generation from by a cadence of 10 years in a decade. Now we are in the era of the 5G. And this picture shows you the 5G super blueprint developed by Linux Foundation networking. It shows you our projects, our community is categorized into several parts like age and cloud infrastructure and management and the orchestration. You can easily find your scenario, your use case can fit in this blueprint to find your interest projects. And now we come to the value of the networks. There is a law developed by Robert McCarthy, the inventor of the Ethernet in 1980s. This is very important rules of the which define the value of the networks. The value is proportional to the square of the numbers of the connected nodes, numbers of nodes on the systems. So you can imagine from an office network, it's a local area network. It has maybe hundreds nodes to scale up to the telecom, the carrier network, all the worldwide network. This will be a very large value of these giant networks. So that is why we consider the companies invest millions, billions of dollars on this kind of networks. And this slide shows you in the 5G, depends on its features. We have using different applications match for the needs of different vertical industries. We are using AI and IoT and also big data, these technologies in different verticals. And it helps the business to gain the profit from the network. So now we have some background of the network and also the you know the value of the network and the ecosystems. And how the network ecosystem is built on. Can you imagine now the network is basically computer systems connected with links, and the modern networks are also developed by open source. I borrowed a picture from the open source OpenSSF. It shows the data of the 90% of the software in the beneath the network is constructed by open source. It's rely a lot of on open source system, the communities. Like your works is contributed the value to all the networks used in the world now. And also Linux Foundation Networking, they developed a landscape to help you easily identify what we are working on and show you some projects and the communities and even the sister communities and other basic network projects outside the AFN. In the left down part of the diagram, it shows you it also connects to the standardization word of the these SDOs, short for standard developing organizations. It's very important to our open source, even to our network, like 3GPP, IEEE, ITU, TM form, something like that. Is anyone doing some standardization? You have some experience on standardization? Please raise your hand. Seems no. And I try to show you some of the different working style on standard works and from the open source. Since everyone is familiar with the open source is sharing the knowledge how you can build this, the code, using code to express your ideas, to establish a system. And but the standard, they are sharing knowledge on what is the technology is actually defined. It's sharing the architecture, the requirements, and also some protocols, and to define the knowledges, technologies. And also the standard method is using text as an output but the open source is using code. They are using different coordination method. One is the left is using protocols, and the open source world is using APIs, something like that. And they have the release cadence is also very different. The open source is developed in release, but it's continue changed by versions. You can always, why we use open source using CI/CD in open source world. But for standard, it needs a set of technical specifications together, to put it together, to release it, maybe using 1 year or 2 years to release a set of standards. And also open source using license to protect itself, and the standard are using patents. Some patents can be embedded in the standard text, and you should claim your rights before the release of a standard. Then you can protect your investment on these technologies. And also, open source is more encouraged people's innovation. People can put your technology into the market very quickly, and standard is almost running on negotiations, and people negotiate the common part of the knowledges, technologies, and released in the standard format to share the technology to the other world. And also the collaboration is different. In standard, you are using drafting and the discussion, and by meetings, people to do your negotiation. And in open source, you should commit your code and review the code committed by others. Then we can work together. That is the difference of the working style between standard and the open source. Open source is also has some interaction between the SDOs. You can see this slide show you the relationship between standardized and the open source community, and even with the contributors and the users of standard and open source. We divide the users into three major parts: the enterprise, the individuals, and also the academics. The standard released the standard in text format, and it consists with the requirements and the protocols. And the open source community can help standard to verify and deploy the technology based on the standard. And also in open source communities, there is upstream from between the different communities. It depends the upstream release and also contributing back as patches, something like that to the upstreams. So the users can have standards and also open source and contributing back to standard with contributions as proposals. And also the open source released its versions and give support to the users. And as the users develop, can also commit and review the codes in the open source community. That is the interaction or collaboration method between the three parties. So we come to the major part of my speak: how to share, to ensure your gain from your investment in the network ecosystems. I should say the IPR is the common way to protect yourself. The patents can be embedded in the standard to protect your innovation method. It helps you easily approve your to raise your evidence that someone using your method against your rights in the patents. And in open source area, normally we're using a license to protect your copyrights, something like that, in your contributing code. It encourages people using your codes, deliver your codes, and should follow the agreement in your license. And also in the market, a trademark is important to protect your brand. These are three ways we commonly used in our world, in the network, in any technologies, any business. But we are also facing some threats in the network. The 5G standards is developed by using a philosophy or principles. It's called the secure by design. It's developed with the circle in mind. First, they use mutual authentication. And the third is to always confirm there's a circle, trustable linkage between the information sender and the receiver. So it assumes you are in a network, it's open, it's not protected by anything else. You should always consider you are in open areas. And it also removing any assumptions that safety between the products. So it thinks any links from the nodes the information can be trapped by misusing, by the attack. So you should architect your network by some kinds of ideas to think. This is the Zero Trust framework released by NIST. And the upper part is the control plane, the lower part is the data plane. So between the information from outside to inside your network, you should using some policy control to verify any danger or threats from the outside world. It is using three points of strategy in these frameworks. So first is continuous verification. The second is limited blast radius. So keep your damage in local areas, not spread all of the infects to all your network. And also automate the logs and with connected logos and also response to the dangers or the defects or attack using some policy to fight back. And also you should always take care of your software supply chain, since the software is now have a lot of components from other open source world. From developer to the consumer, there's several points for the weakness from the attack. Thanks for the open SSF, they gave us this diagram. And they have a lot of work developed by using this chart to tell us how to protect your software. And the last of my consideration is recommend you to diversification your risk using a risk diversification mechanisms. You must make sure that you can always connect to the outside, connect to the open source communities, the standard bodies. They are using a redundancy architecture, or in backup or in federal architecture. That is all my sharing in these sessions. If you have any question, please let me know if you have any questions. Yeah. Seems no. Thank you for coming here for listening, and I think we can have our lunch. Thank you. Very appreciated.